consultants. This assignment required student groups to each source an appropriate civil engineering case study, along with the relevant contract documents for comprehensive analysis of the scope and measurement of the works. The civil engineering case study selected should be a current or recent project within the Greater Cape Town metropolitan area. The analysis to be performed should focus on critically evaluating the bill of quantities received from the civil engineers with specific reference to the measurement of the works provided for in the SANS documents. Due to time constraints and confidentiality issues, it is very difficult to get hold of contract documents from the civil engineering companies which were contacted. As a result, integral cost consultants decided to use a case study that has already been used and analyzed by past groups. The case study chosen was the Vines, which was utilized by DMK cost consultants in 2015. Only the case study contract documents were used from the previous assignment and proper analysis of those documents were carried out. Overview of the case study. The case study being examined is the Vines in the Valdevie estate in Paarl. Valdevie is one of South Africa's most premium estate developments. This estate is also internationally recognized for its design, lifestyle, and polo facilities, achieving numerous accolades at the International Property Awards. The Vines project comprised of the construction of 142 residential units, as well as roads, sidewalks, and pathways, and modifications to the existing dams and civil services. Pule.
Okay, I'll take you through the climate and location. Climate. The climate in the area can be described as warm and temperate, with higher rainfalls in the winter season than in the summers. Average annual temperature of 17.6 degrees Celsius, with an average rainfall of 770 millimeters. Location. Valdevia is situated in the Boland region of the Western Cape. This residential estate is approximately a 54-minute and 40-minute drive from the central business district of Cape Town and Cape Town International Airport, respectively. More specifically, the estate is in the heart of the Cape Town Winelands, or Cape Winelands, where it is surrounded by mountains, the mountains of Paarl, Franschhoek Valley. Procurement of the works. The procurement strategy with regards to the case studies selected are as follows. Vision Africa Services Limited was approached by the client as the principal consulting civil engineer. Vision then employed NMC Civils as the main contractor to carry out the works. I'll now hand over to Pagden.
I'll be taking you through the work description. The works include the construction of 142 luxury residential units, the modification of existing dams on the 12 hectares of prime land. The work was undertaken by NMC contractors. In greater detail, the scope of works consists of site clearance, the clearance of the 142 plots of lands of vegetation, earthworks. The earthworks involved are extensive. It includes the leveling of the plots of land where the residential units will be situated. These works will be completed by means of cut and fill operations. The contractor made use of the earth obtained from the excavation of the dam that could be used as backfilling. Road construction. In order to perform the works for the road construction, the contractor must divert all traffic in order to prevent blockages and congestion of surrounding roadways. For the construction of the road, the contractor was required to import non-cohesive drainage sand. The sidewalks are to be finished off with a blinding layer of sand in preparation of receiving paving at a later stage. Gabions. Dry packed stone walls that are contained neatly in wire mesh baskets. Gabions were used on portions of the dam for erosion control. Modification of existing dam. The works entails modification of the existing dams in accordance with the design specifications. In terms of the backfilling for this project, and apart from the use of imported materials from borrowed pits, the earth obtained from the dam's basin were rendered reusable by the engineer, and therefore it is required that the contractor make use of the sediment. Here is a brief summary of the scope of works in the project.
I will will now take you through the SANS 1200 documents. Just like quantity surveyors use the ASAQA standard system to measure building works, civil engineers use the SANS 1200 standardized specifications in order to build up bills of quantities. This civil engineering standard system split different civil engineering works into various SANS 1200 documents. For the purpose of this assignment, only site clearance and earthworks, that is, SANS 1200C and SANS 1200D, respectively, shall be scrutinized. SANS 1200C deals with the removal of vegetation, boulders on site, not exceeding 0.5 meter cubed, surface obstructions, fences, existing buildings, and dismantles steelwork. For this project, the site must be cleared so that the construction of buildings can proceed. I will now be evaluating the bills of quantities that the project has. The first section is the clearance and grabbing of the material. General notes from SANS 1200 include the item being measured in hectares, the site area to be cleared and grab measured to the nearest 0.1 hectares, pipelines with specified width shall be measured into the nearest meter or kilometers, and the removal of trees not exceeding 1 meter girth and boulders not exceeding 0.15 meter cubed are included. When comparing that with the BOQ that the project has, clearing and grabbing of earthworks and roads are measured in square meters instead of hectares, and pipeline measured followed the standards of measurements as required. For the removal and grabbing of trees and large tree stumps, when we look at the BOQ, all trees were measured in number, which is required, and trees and tree stumps were measured separately. This does not follow the standard system, as they were supposed to be measured together with respect to the girth category stated, which are exceeding 1 meter and not exceeding 2 meters girth. The other one is exceeding 2 meters and not exceeding 3 meter girth, and thereafter exceeding 3 meters in succession of 1 meters respectively. Also, the BOQ shows tree stumps measured exceeding 0.5 meters and up to and including 2 meters. This isn't in accordance with the standard system of measurement, as firstly, tree stumps aren't measured separately with trees, and secondly, the relevant category is exceeding 1 meters and not exceeding 2 meters girth. Trees with girth not exceeding 1 meter are measured under clause 8.2.1 clear and grab. Moving on to the removal of topsoil. As we look at the BOQ that the civil engineers measured, the item measured is referred as clause 8.3.1.2 of SANS 1200D, which is for the removal and conservation of topsoil. This is correct, as the topsoil has to be conserved as per clause 5.6 of SANS 1200C. This item should then have been measured under earthworks trade bill instead of site clearance. The other thing noted is the unit of measurement was meter cubed instead of meter square, therefore the quantity will be different. And the last part is finishing topsoiling and grassing was placed under site clearance while it is under earthworks, clause 8.3.10 of SANS 1200D. This item should have been under the earthworks trade bill. And lastly, for this section is take down existing fences. As per the SANS 1200C, the unit of measurement is kilometers, but we see from the BOQ that they've measured in terms of meters. Therefore, they did not follow the standard system, which was supposed to be which had to be kilometers. And now Hader will take you through the SANS 1200D.
Thanks, Mercy. So, the first thing that was noted in the earthworks BOQ is when we look at the bulk excavation, item 5.1 was measured according to the payment reference 8.3.2, and the comparison is that instead of the engineer using cut to stockpiles and cut to fills, he should have used bulk excavations, which is in accordance to the SANS 1200D document. Additionally, item 5.1 is accordingly separated. The excavation of soft sediment from the bottom of the dam has been accordingly separated following the SANS document, which is in a proper order. As for the item 5.4, the engineer had one item for extra over for all the different types of excavations in 5.1, 5.2 and 5.3. The extra over presented in BOQ was for Class A boulders only. No extra over item was measured for intermediate excavation or hard rock excavation, which might have been the case on the site. That's why they decided to include only Class A boulders and not intermediate excavation or hard rock excavation. Next, we have the importing of materials, which is payment reference 8.3.4. Item 5.6 and 5.8 distinguishes everything accordingly as required from the SANS document. It separates borough pits and commercial sources. Item 5.6 and 5.7 is measured according to the SANS 1200 document. That is, it's measured in meter cube and as a sum, respectively. It should be noted that item 5.8 is not measured as an extra over, as was required by the SABS document. However, the unit of measurement was correct. Next, we have item 5.5, which was measured as an overhaul. However, this item was measured as an extra over to item 8.3.2, but it's measured in meter square when the SANS document requires the measurement to be in meter cube. Next, we have existing services. As we noticed in this BOQ provided by the civil engineers, there was an obvious typo. Instead of saying 8.8.4, it should have been 8.3.8 for the payment reference, because the SANS 1200D document ends at 8.3.13, and while looking at the items that the civil engineer had in his BOQ and comparing it to the actual document, it could be noticed that it wasn't a typo. Items 5.10, 5.11 and 5.12 made reference to the location of existing services as identified by clause 8.3.8.1, item A to C. All the subsections were measured accordingly, except for B, where it should have been measured in normal working hours, but was however measured in number of days. This item of topsoiling wasn't referenced, and while looking at the SANS document, we noticed that item 5.9 could be linked to topsoiling, as the description is the same. However, the units of measurement was in the civil engineering BOQ is meter cube, where in the SANS document it's in meter square. For the geotextile item, this item was not in the SANS 1200D, but was found in the SANS 1200DK, and it's the payment reference 8.2.4 and is measured in meters square as it's measured in the BOQ. The last two items, 5.14 and 5.15, did not fall under any of the clauses of 8.3, which is the scheduled item. It was therefore unable to locate the specific clauses which address dewatering. The engineer, however, used those two items as a sum, which might be for an allowance, should dewatering be needed. In conclusion, it can be said that on completion of this assignment, the whole ethical consultant group had a better understanding of the SANS document, more specifically SANS 1200C and SANS 1200D. The most important information in the bills of quantities is the payment reference. Without this piece of information, it would be very difficult to understand how the works were measured, as some of the items in the civil engineering BOQ were not referenced. It was difficult for us to locate where those items were coming from. Additionally, we also concluded that the SANS 1200 series is only a guide for the civil engineers. This is because even though everything has been laid out in a certain way in the SANS document, civil engineers do not necessarily follow those rules. These specifications is fluid in nature and can be shaped in any way that the engineer wants, as long as a comprehensive bill of quantities is produced. Thank you so much for